since I want to talk about features of a polynomial graph, I think we should probably look at a polynomial graph. So, here we go. And whoops. That. A little bit. All right. So as far as features of a polynomial graph, so here's a graph polynomial. There are a list of things that we need to be able to identify. As far as that list goes, we need to talk about domain. We need to talk about range. We want to talk about intervals of increasing. No. Actually, I want to talk about max, and then mins, and then I want to talk about increasing, decreasing, and zeros. Okay, so first on our list, domain and range. Domain. Simply put, how far left and right we go. The official title of domain are your x values, but the way I want you to think about that is how far left and right you go. So, as we're walking, if I'm an ant walking to the left, how far left does this graph go? Another way to think of it is there anything restricting me moving all the way to the left? Right? Is everybody? So if I'm looking for, you're looking for restrictions. Are there any restrictions moving all the way to the left? There's no walls or anything. So we go all the way to the left. Also, similarly, are there any restrictions as we go to the right? So our domain, right, is actually going to be everything, right? And actually, for any polynomial, your domain is everything. And when we write that in interval notation, that means our domain is going to go from negative infinity to positive infinity. Okay. Okay, next up, let's talk about range. Range, officially, those are your possible y values. But practically, when you're looking at a graph, it's how far up and down the graph goes. And so so we're looking for y values. How far down does this graph go? It goes all the way down, right? What's the highest this graph goes?
All the way up.
No, it doesn't go all the way up. What's the highest y value it gets to? 5, right? Right? Doesn't go all the way up. If it went all the way up, the graph would be, go pointing towards it. It doesn't go all the way up, right? So if I want to talk about my range of this, my range is going to be from negative infinity, and it goes into a y value of 5. Now we get to include the 5, but with infinity, as far as interval notation goes, we always use parentheses, right? So now we're going to talk about, that's our range. We've got domain and range. So domain, every polynomial, your domain is negative infinity to positive infinity. There are no restrictions. There's nothing that stops it going all the way left and all the way right. As far as range goes, you have to look at the picture and you ask, how low does it go? Right? In this case, it goes all the way down. How high does it go? Well, maximum y value is 5, and so that's where I have our range of that. Now let's talk about maximums and minimums. Technically, they're local max and local mins, but so maximum and minimums, those are peaks and valleys. Like a peak, that's a maximum, like it's bigger than the points around it. A minimum, that's a valley. It's lower than the points around it. And so if I look at this, can everybody see is that a max or a min? Max, easy, right? All right, so easily a max, it's like that's our peak of a mountain. And so the coordinates of that peak are going to be negative 3, 4. What else is a maximum? Any other peaks in this graph?
4, 5.
4, 5. Okay, any more peaks? Okay, any valleys? All right, those are our peaks, right? Any valleys?
1, -3.
1, -3. All right. So when I talk about maximums, technically they're called local max and local min. But when I talk about peaks, or when I ask for maximum minimums, I'm looking for those peaks and valleys. Everybody okay with that part? Right? Now let's talk about increasing and decreasing. And usually the question is, where is it increasing and where does it decrease? Now, this is not just for this type of problem. This is anything in a math class. Anytime a math teacher talks about where something happens, that means they're talking about x values. If they ever talk about what, that means they're talking about y values. All right? And so what I'm going to do is, now when you talk about something's increasing or decreasing, that talks about going uphill or downhill. And the way I want you to imagine an ant walking on your graph. And very importantly, the ant is walking from left to right. Now, that's very important. You read left to right, that's how everything's set up. And so if I'm reading left to right, can we see that the ant is walking uphill here and here? Is everybody okay? That's our ant walking uphill. And our ant is walking downhill here and here. Okay? Are we okay that in our graph it's easy to identify when you're going uphill and when you're going downhill? Now, if I'm looking for intervals of increasing and decreasing, I'm asking where is it increasing and where is it decreasing, meaning I am looking for x values. So you need to know the x values that are associated with this part. So I'm going to color code it. Can you see that these are x values associated with the graph increasing? These are x values associated with the graph increasing. And these are the x values associated with the graph decreasing, and these are the x values associated with the graph decreasing. Now, as far as our color coding goes, let's talk about increase. Okay? Okay. So as far as my x intervals for increasing, it's going to be from here to here. So that's going to be from, what's that, negative infinity to negative 3. And then the next interval of increase is from 1 to 4. You see how I got those x values?
Wait, but don't you include them?
What?
You have to include them.
I'm going to talk about that. Okay? And then as far as our intervals of decreasing, it's going to be from here to here. So it's going to be from, what's that, 3 to 1. Sorry, negative 3 to 1. And then from 4 to infinity. Now, you asked the question that's always asked, so I'm glad you asked it. All right? And then the question is, what, shouldn't I include it? Shouldn't I include the negative 3 and shouldn't I include the 1? Well, so here's my problem. So here's my issue with that. If you're at the top of a hill, are you going uphill or downhill? If you're at the very top? Neither, right? You're going flat, right? You're not going up or down. And since you're not going up or down, you don't include it. Does that make sense? Okay, so that's one explanation. The other explanation is, all right, you get to include it one way. You get to include the negative 3. So is that negative 3, is that part of the increasing part or is it part of the decreasing part? You really can't pick one, can you? And since I can't pick one, we don't pick any. And so your intervals of increasing or decreasing don't include the peaks or valleys. Because at the peak or the valley, technically, you're flat. You're not going uphill or downhill. You might be about to go uphill or about to go downhill, but at that flat spot, you're still flat, and so you don't get to include the increasing, decreasing part. All right, and the last part. We need to talk about zeros. And we talked about this on Thursday. As far as zeros go, You look for where this thing crosses the x-axis. Those are the zeros. Those are the places where the y value is 0. And we're actually going to talk a little bit more about that later, the second half of class. And in this case, my zeros are, looks like they're -5, -1, 3, and 6. You see that? So my zeros are going to be -5, -1, 3, and 6. So just curious. How much work did we have to do to list those properties? Like no work, right? All this is a chart describing our picture. Curious, what is the degree of this polynomial?
4.
4, right? See how it looks like a parabola with some waves in it? Right? Anytime you have a parabola with some waves in it, okay, that's degree, depending on the number of waves. This doesn't have many waves, so this is degree 4. Curious, also, another question. Is the leading coefficient positive or negative? Negative, why?
Because it's like going down.
Because it flipped. Remember, our regular degree 4 is like a W looking thing. And since this is flipped, that means this leading coefficient was negative. Right? So all we're really doing is describing. All right, your turn. Pause just. So, what's our domain? What's our domain for every polynomial? Negative infinity to positive infinity. There are no restrictions. There's nothing to stop it. So this domain goes from negative infinity to positive infinity. Range. How far down does it go? All the way. How far up does it go? All the way, right? I know it's got these little peaks and valleys, but as far as range goes, it's how far down and how far up do we go? So our range is going to be from negative infinity to positive infinity, right? Do we have any maximums? Yep. We got a couple, right? Are we okay? Those are my maximums. Those are my local max. Those are my peaks. And so that's going to be -5, 5, and then 1, 3. Do we have any minimums? Yep. Here and here, so what's that? -3, -4.
That was at -2, 4.
-2, 4. Yes. -2, -4, and then 1, 3. But 3, 1. 3, -1. Whatever that dot is, right? Yes. Yes. Okay. So we okay with that? Now, the part that sometimes causes students trouble, where is this thing increasing and where is it decreasing? Right? We're looking for x values. I think everybody can easily identify that it's increasing from here to here, here to here, here on, right? Can everybody see that? If you're the ant walking on the graph from left to right, you're going uphill here, and uphill here. The trick is you have to give me the x values that correspond to that. And my x values are these x values, and those x values. Everybody see these x values correspond to us going uphill? And these x values. So this is increasing from negative infinity to -5, Then from -2 to 1. And then from 3 on. And then as far as decreasing goes, it's the rest of them. So from here to here is decreasing, from here to here is decreasing. So it's like from -5 to -2. And then from 1 to 3. We okay with that? And the last bit, the zeros. Is it easy to identify the zeros? Because we talked about that Friday, so our zeros are going to be here, 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 here. Any place the thing crosses the x-axis. And so we get -7, then -3, 0, 2, 4. All right. What could the degree of this polynomial be?
X to the fifth.
Something x to the 5th, right? And one key giveaway to this is, how many zeros do you have?
5.
Everybody see you have 5 zeros? If you've got 5 zeros, that means this could be, this thing has to be at least degree 5. Because if you've got 5 zeros, you better have at least 5. It better be at least of degree 5. Does this make sense? Are you having to do a whole lot of computation here? Are you having to do any computation? I mean, all this really is picking up information from the graph. All right, are we okay with this? You will have a question like this on your test, where there is some picture and you have to tell, okay, when you have max, local max, what's your domain, what's your range, where is it increasing, where is it decreasing, where are the zeros? And I want that to be an easy question. All right? Okay, next up. All right, is everybody okay with this? All right. So actually, let me pause this. So what I want everyone to do is write down, I want you to write down this polynomial. X minus 2, x plus 3, x minus 5. So I'm going to have a polynomial, and our job is I want to graph this polynomial. I want to sketch. My goal is not to get an awful lot of detail. My goal is just to provide a sketch of this polynomial. So everybody written this down? All right? Well, if I want a sketch of this, I'll put a little coordinate plane. Oh, actually, before we do that, I want to know the zeros of this polynomial. And how you find the zeros is we're going to set this equal to 0. And my job is I want the zeros of this polynomial. I'll go ahead and tell you there are 3 zeros. Does anyone have an idea what those 3 zeros might be? What one of them might be?
2.
2. What makes this 0? Is everybody okay? The 2 makes this 0? So one of my zeros is 2. What's another 0? -3. And what's another 0? 5. Is everybody okay with that? Are those easy to identify? So what makes this 0? What makes this 0? What makes this 0? Now, as far as graphing goes, here's how it works. Okay, so here's 2, here's -3, here's -5. Label your zeros on the x-axis. If you want to put all the other numbers in, you can. Doesn't matter. All that does matter is that these are in the proper order. Right? It wouldn't make sense if -3 here and -5 was here, but you know.
It is supposed to be positive 5.
Yes, it is. As I said, positive 5. Okay. All right, so are we okay if this is your polynomial? Are you okay identifying the zeros? So we've identified the zeros now, and we've plotted them on our grid. And since these are zeros, I want you to go ahead and put dots at the zeros. So put a big dot here, put a big dot here, and a big dot here. All right. What's the degree of this polynomial?
X to the third.
X to the third. Everybody okay? It's x to the third? Is it easy to identify it's x to the third? All right. What does an x to the third graph look like? Like an S, doesn't it? Right? Starts here, does this, right? That's what a cubic, that's what a degree 3 graph looks like. It starts at the bottom and it does stuff. All right, well, we're going to draw our degree 3 polynomial. You just told me it started at the bottom, or you did little hand motions where it started at the bottom. So we start at the bottom, we're going to hit this dot, and we're going to go up. I don't know exactly how high, and I really don't care. All I know is it's got to come back down to hit this dot. And it goes down, and then it's got to come back up to hit this dot. And I've done a rough sketch of that polynomial. Is this the exact graph of this? Probably not. But this is a rough sketch. Does it look like a degree? Does this look like a degree 3 polynomial? Does it have that little S shape? All right, your turn. Actually, I need to erase this. So let's give you x plus 4, x minus 5. I want a graph of this. So what are my zeros? -4, -2, 1, 5. Everybody okay with that? And so if those are my zeros, I'm going to plot those on my graph. So let's see, here's -4, here's -2, here's 1, and here's 5. And I'll go ahead and put my dots here. And what's the shape of this? What's the degree?
4.
It's degree 4, okay. So it's degree 4, so what's the shape going to look like? Parabola. Where is it going to start? Is it going to start from the? Is it going to start down? Or is it going to start up? Up. That's just what parabolas do, right? So our parabola is going to start up, and then we just got to make sure we hit all the dots. So I'm going to start here. This dot goes. Kind of a general rule of thumb. If you want to know how far down, below, above, far away from the x-axis, if the two dots are really close, you don't get a chance to go very far down. But in this case, where the dots are further away, we go up a little bit higher. And these dots are further away, so I can go a little bit lower. And when I'm done, does that look like a degree 4 equation?
How'd you know it was turning up?
Because it's positive.
Oh, okay.
Because if it was like the other example, it was down because, well, I drew it down. Does this make sense? All right. Gotta hurry. Hopefully I can get through this. All right, so next problem. So I want to graph this. What are my zeros? Okay, so our zeros are going to be 1 and -2, and you think, well, that's not that big of a deal. Okay, so here's 1, here's -2, right? What's the degree of this polynomial? 2, so it's a parabola. Okay, well, duh, right? But done, right? Not a question, right? Not really much of a question compared to what we've been doing. All right, well, what if I change it a little bit and I say, well, what if it was x minus 1 squared times x plus 2? Right? Because if I compare this polynomial to this polynomial, the zeros are exactly the same, aren't they? Like, what are my zeros here? 1 and negative 2, right? And so if I'm graphing, well, okay, here's 1, here's negative 2, I get dots here, and I get dots here, right? But is this graph going to be the same as this graph? No, it can't be. What's the degree of this polynomial?
3.
3. If you multiplied everything out, everybody agree with big x cubed? And so if it's x cubed, right, we're looking for an S shape. Well, how do we draw it? Where's it going to start from? If it's x cubed, where do we start? Remember, x cubed did the S thing, so it starts here and does this, right? Right? That's what an x cubed graph looks like, right? It does this, right? So we know an x cubed graph does this. Now, are all zeros created equal? In this case, are all the zeros the same level of importance? Well, obviously by the question, right? Which zero do you think would be more important in this case? I think the 1 would be. See, let's say that you wrote this out, right? Because if you wrote this out, you'd say it's x minus 1 times x minus 1 here, right? So if I were to write this out, I'd say, okay, that's x minus 1, and that's an x plus 2. And if I were going to list all of my zeros out, well, okay, I'd get a 1 here, a 1 here, and a negative 2 here. So it's like you've got 1 twice, doesn't it? Because I have 1 twice, something weird is going to happen at 1. Does that make sense? They actually have something, it's called multiplicity, right? And officially, I think if you were to look up in your book, and they said, right, a lot of textbooks will do this as 1 multiplicity 2, and then negative 2. To tell you, like, the 1 should be counted twice. All right? Okay, that's fine. How does that give me a picture, right? I think, are we okay that we have to count the 1, we have to say that has multiplicity 2 because we have 2 of them?
Do you write it as like an x1 or you just do m2?
M2. For multiplicity 2. You got 2 of them. So I need to talk about how does that, if it's got multiplicity 2, how does that impact what your picture looks like? Well, here's how it works. First, we okay this is degree 3? So we're going to start here and end up here, right? That's what degree 3 does. And so if I start here, okay, negative 2, nothing weird happens. Like, we're just going to pass through it because that's what we do, right? That's what we do if we're here. And if it's multiplicity 2, and I don't have enough time to explain why it works this way, I will have time tomorrow. If it's multiplicity 2, what ends up happening is it bounces. And what it ends up doing is it kind of makes a little parabola. See, if it's 1 multiplicity 2, see how it kind of makes a little parabola at 1?
So it doesn't go underneath the
No, it just bounces. And does that picture look like an x cubed graph? All right. Your turn. Graph that one. Our zeros are the same. We have a 0 at 1, and we have a 0 at negative 2. Are we okay with that part? So if I put my little dots in, okay, I know my graph is going to go through this dot, and it's going to go through this dot. And it's degree 3, so where is it starting? Starting at the bottom, all right? Now, in this case, the multiplicity 2 is with the negative 2, right? So it's going to bounce at negative 2. Are we okay? All right, so are we okay that we're starting here? So we're going to start here, and at negative 2, we're going to bounce. See how it creates that little parabola? And it goes down. I don't know exactly how far down, and I don't care, but I do know that it's just going to pass through the 1. And does this look like a degree 3? We get a degree 3 equation. All right. Okay. Draw that one. Okay. So what's the degree of this?
4.
It's degree 4, all right? We still have our same zeros, so I've got 1 and negative 2. And since it's degree 4, where is it starting? Starting at the top. And so negative 2 is normal, but the negative 1 has multiplicity 3. Now how do we handle that? Well, if it starts at the top, it just passes through, because that's multiplicity 1. It passes through multiplicity 1. What does it look like when it's multiplicity 3? Well, multiplicity 3, it should look like it looks like an x cubed graph. What ends up happening is it levels off and then passes back through. So at degree 3, anytime it's degree 3, it's going to do this little S shape. And I'm going to explain why tomorrow.